Today's lesson is on simplifying radicals and complex numbers. You should memorize your perfect squares and roots up to 20 squared equals 400. I've just put the first 12 here for you just so we can reference them today. The square root of 9 is 3 simply because 3 squared is 9. So the squares and the roots work together. But the square root of 9 is not plus or minus 3. That's a common mistake, and we'll talk more about that later. Here are a couple properties of square roots that are going to help us simplify today as we get going. So you can multiply roots together, put them together, but you can't add them and put them together that way. For example 1, let's simplify the square root of 20. Now what we want to do is look for perfect squares that go into 20 since 20 is not already perfect. So I start down my list and say, well, don't really worry about 1. Does 4 go into 20? Yes. But you want to keep going and make sure you have the highest possible perfect square that goes in. So what I'm going to do now is take the perfect radical, which was 4, and figure out what I need to multiply that by to get 20. And 4 times 5 is 20. Now that I intentionally picked a perfect radical, I can take the square root of it. So the square root is 4. The square root of 5 we don't know, and so we're done. Alrighty, let's do 32, the square root of 32. I check my list. Does 4 go into 32? Yes, but I want to keep going and see if I can find something higher. What about 9? No. 16? Yes. 16 is the highest. Once you check the numbers halfway, you know there's nothing bigger that's going to work. So I put the perfect radical first, and 16 times what is 32? 2. And now, remember that's perfect because we picked it that way. And the square root of 16 is 4, so we get 4 radical 2. When I see perfect squares, I kind of like to circle them. Helps me keep track of stuff. Now, multiplying these together, you multiply the regular numbers together and you multiply the radicals together, but you leave them under. So that's the square root of 18. Now, I happen to notice that the square root of 18 can be simplified. So I'm looking on my list and saying what goes into 18, what perfect square? And the highest one is 9. 9 times 2 is 18, so I get 10. And here, that's perfect. I get a 3, and we still have the radical 2. Now I need to multiply these together, and I get 30 radical 2. Final answer. Example 2, let's recall that we need to rationalize denominators. We don't like leaving radicals in the denominator. So we always multiply by 1. Multiplying anything by 1 doesn't change the value. For example, you have the number 7. You multiply by 1, you still have 7. But this one is going to be fancy. And I'm going to pick radical 7 over radical 7. Whatever that denominator is, that's what I use. Remember, anything over itself is 1. So now I have the square root of 14 on top and the square root of 49 on the bottom. By me picking matching numbers, that's really just 7 squared. So the square root of 49 is 7. So from the beginning, I knew that when I multiplied those together, I was just going to get 7. Now, important to know that you're done. You cannot divide this 7 into the 14. Only radicals with radicals. Okay, now on part B, I want to get rid of the denominator. And remember, you can always pause the video and try the problems for yourself. That's always a great idea. So I'm going to multiply by my magic 1. This time it's radical 6. Notice this one changes often. So on top, I have 4 radical 6. And on the bottom, I have radical 36, which is just 6. But I can't stop there because you always have to reduce fractions. And 4 over 6 can be reduced. 2 goes into both of them. So 2 goes into 4 twice and 2 goes into 6 3 times. And the radical 6 is still the same. Alrighty. Let's talk a little bit about complex numbers. Complex numbers in standard form look like a plus bi. The a is the real part, and these are the types of numbers that we're used to. They can be fractions, decimals, even pi is a real number. Now, imaginary numbers are going to have this I attached to them. This is the imaginary part. So, what is I? And the first thing I want to make sure you know is that I is not a variable. Sometimes it behaves like one, but a variable is in place of a number. I doesn't necessarily represent different numbers at different times. So it doesn't vary. It's not a variable. It has a value equal to the square root of -1. And if you square both sides, you get I squared equals -1. Both of these are going to be super helpful in simplifying our problems today. So why do we need I? It allows us to take the square root of negative numbers. In the past, we haven't been able to do that. Now we can. So using those properties to simplify, now I can say, well, 36 is a perfect square already, and then put -1 by itself. And what is -1? We just learned. The square root of -1 is I. So now what I have is 6i. So the square root of -36 is 6i. It's imaginary. And what you're going to find when we start solving quadratic equations, when they have imaginary solutions, that means no x-intercepts. So this is going to be a really big deal. Okay, here I'm going to have to do a little extra work because 200 is not a perfect square. So I'm going to have to figure out how to further break that 200 apart. 100 is a perfect square. So I can say 100 times 2 times -1. And now I want to simplify. I like to circle my perfect squares. That's 10. The square root of 2, can't do anything with that. And the square root of -1 is I. Now, math etiquette says radicals go last. Radicals last. So I'm going to put 10i radical 2. And that's just having good math manners. Alrighty, let's look at this problem. Well, I see that I can simplify what's under the radical. I can break that apart to 4 because 4 goes into 8 and that's a perfect square. I can go 2 and -1. So let's see what's going on. That's a perfect square, so I'm going to take the radical sign off. A common mistake that I see is that students take the square root, but they forget to take the radical sign off. And the square root here is I. So let's multiply and put everything in a great order. Looks like negative 6I radical 2. And that's a great answer. Alrighty, let's kick it up a little bit. Although I is not a variable, it sometimes behaves like one. So I'm going to distribute the 2, and I get 14 plus 12I. Now I need to distribute the negative sign. Negative, negative is positive. And now I need to combine like terms. So I'm looking at 14 and negative 3 is 11. And then I'm going to combine the i's. So I have 14I. 12I plus 2I is 14I. And that's all I can do with that. And notice it's already in standard form. I have the real part first and then the imaginary. Example 5. It'd be a great idea if you pause and give it a try on your own. Okay, hopefully you tried it. Let's see if you got it correct. I'm going to distribute the 4I, so I get a negative 24I. And now 4, that's positive because it's positive here and positive here. And now I times I is I squared. Oh boy. Remember, I squared equals negative 1. So I'm going to take the I squared out and put negative 1 in its place. And right here, multiply by negative 1. So I'm looking at a negative 24I minus 4. But hopefully you notice right away that's not in standard form. You want the real part first and then the imaginary part. All of these math rules. Okay, let's have a look at part B. We do want to do first, outer, inner, last. So we multiply here and we get 54 for first. Outer gives me 9 times 5 is 45I. Inner is a negative 12I. And last, that's a negative 10I squared. Watch out for that I squared. We're going to replace that with a negative 1. And now I notice that this is just 10. So 54 plus 10 gives me 64. And when I combine my i's, I get 33I. And that is in a great order already. Let's move forward to example 6. I'm sure you'll get these on your own. So pause and give it a try. Okay. First, now let me see if you notice anything about these problems. Each part is the same except for one is plus and the other is minus. These are called conjugates in math. These are conjugates. The first one, we say those are imaginary conjugates. Okay, so when we do first, we get 4. Outer is a minus 6I. Inner, positive 6I. And last, let's be careful. Positive 3 times a negative 3 is a negative 9. I times I is I squared. So, of course, we need to put that negative 1 there. But here's what I love about conjugates. The outer and inner always cancel. And so now, there's no more I. And it always happens that way with conjugates. The I's go away. And so you're going to find later in pre-calculus that we use conjugates as a tool to get rid of imaginary numbers. And hopefully we have some extra time I can show you this year. Now, again, we have conjugates, but these are radicals and imaginaries. And guess what? Conjugates get rid of all the imaginaries, all the radicals. Let's see how it'll go. 4 times 4 is 16. Outer. Remember, outer and inner cancel, but I'd like for you to see it. We get 4I radical 2, and on the inner, positive 4I radical 2. And last is where it's going to get crazy. We got positive times negative, so that's negative. We got I times I, that's I squared. Radical 2 times radical 2 is radical 4, which is just 2. So remember, those are the same, they cancel. So we get 16. I squared, watch out for this negative, it's still there. We got a minus in the middle. I squared is negative 1, and that's just 2. So that's just 16 plus 2 is 18. And notice the radicals and imaginaries all went away and just left us with a simple number. Alrighty, let's go ahead and look at our last example. We're going to square it. The common mistake would be that people think you can just distribute like that. And I say, no way. Remember, when you have binomials squared, you have to write them twice. Same thing twice, not conjugates. This is positive, so we make both of these positive. And now we can FOIL, and we get first, outer, inner. So outer and inner are the same. And last, be careful. 2 times 2 is 4, and I times I is I squared. So the I squared is going to become a negative 1. And notice here, these are like terms, so we get 32I. We got 4 times negative 1. So now we can combine our like terms. And we get 12 plus 32I. And it's in a great order, so I'm going to box that up. Let's look at our last example. So negative 2I to the 4th power. There's no addition in there, so here we're actually going to do this 4 times. Uh-oh, I forgot my I there. Oh, boy. Gotta have that. 4 times. And this is just one way to proceed. Now, we're going to multiply all those negative 2's together. So I see negative 2 times negative 2 is 4. And I see negative 2 times negative 2 is a positive 4. I times I is I squared. And I got another I times I, that's I squared. Now this is all multiplication. Don't get confused and start adding anything. It's all mushed together. So now I can say 4 times 4 is 16. But look at this. I squared is negative 1. I already multiplied those 4's together. And then I have another I squared is another negative 1. And so negative times negative is just positive 16. So all the I's went away. Yay.